Okie dokie. Hello guys again. This problem it was solved before using the law of sine and law of cosines. And we have non-perpendicular axes. So let's study another way to do that. And actually the problem is asking you to do that. The problem is asking you to say find the components along the U and V axis of each one of the forces and then find the resultant force also. How do we do that? Procedure is similar, is the same, but now we are going to decompose this force F1 into the UV axis. How do you do that? Same situation. You draw lines parallel and perpendicular to the axis, so this is going to be for force 1, and in order for the force 1 is going to be the resultant of that. So you see, so basically I need to go here and here. This is going to be for that one. So if I need F1, what does that mean? F1, I'm going to have this component for F1 in the U-axis, and it's going to be positive because it's pointing in that direction, and this component of F1 in the V-axis, and it's going to go in that direction as well. So we have this little triangle here that we have to use for that. How are we going to handle this thing? Same situation, remember. This angle here is 45 degrees. This is 75, this is 30, meaning this angle here between this and this should be 45 degrees. 45 degrees here. Now I have that angle 45 degrees, and I have this resultant force here as well. Now, can I know how much is this angle here? How much is this angle here? Look at this line, look at these two parallel lines, so that angle should be 30 degrees. And if this is 45 and this is 30, meaning 75, this has to be 105 degrees. Why 105 degrees? Well, because 105 degrees plus 75 is 180, and that's what it's supposed to add when you add the internal angles for the triangle. So let's just put that into. One of the things that you have to just keep in mind is that when you don't have perpendicular axes, you have to use the law of sines and law of cosines. So just do the law of sines for this. I know this value, which is 4. So I can start by saying 4 divided by sine of 105. What I have is this triangle. Look, I'm going to copy the triangle here just to make it easier for you to see. This is 4, which is the value for F1. This angle here is 105. This is 45. This is 30. And this value here will be the component of F1 in the V-axis, so F1V, and this one will be the component of F1 in the U-axis, F1U. So let's do that. 4 divided by sine of 105, 4 divided by sine of 105, opposite with opposite, has to be equal to F1U divided by sine of 30, and at the same time it has to be equal to F1V divided by sine of 45. So from here I can use this part and solve for F1U, and I can use this part and solve for F1V. So for F1U will be 4 divided by sine of 105 multiplied by sine of 30. Now I change this somehow, and this is what happened to the students in the middle of the exam, and they don't know how to work with that, because you see now it's giving me the answers in that way. So it's good that it happened, but I honestly don't remember. I know there is a function that exists. Let me see, here. That's the value, 2.07, and the units are kilonewton. Now, if I use the other one, which is this one, now it's going to be 4 divided by sine of 105 multiplied by sine of 45. So 4 divided by sine of 105 multiplied by sine of 45. And that will be, again, so I have to make it permanent in this part. So answer, there you go, 2.93. These are the components of F1 in the U and V axis, and both of them are positive. Now let's focus on F2. Let's do the same thing. I make it line, parallel and perpendicular. I'm going to use blue for this one. So make a line parallel to the U axis and a line parallel to the V axis here. So in order for me to decompose F2 into the U-V axis, it has to come all this way, which is positive, and then this way. And this component will be negative, because this is pointing in the opposite direction of the positive of V-axis. So this is going to be a negative value. If the problem asks you to express the components, if the problem asks you just to find the magnitude, it doesn't matter because magnitude is always positive. And I know this value is 6. Now, what else do I need to know from here? Let me see. Do I need to know this angle? Well, yeah, I know that angle because this line are parallel. This angle is 75 degrees, and then this angle here, if this is 75 and this is 30, that's 105, and it has to add 180, so this is 75 as well here. Now we can calculate this and calculate that. How? Using the law of sine. So I can say 6 divided by sine of 75 has to be equal to this divided by this has to be equal to this one. What is this one? This is F2V divided by sine of 30, but at the same time it has to be equal to this one, and that's F2U divided by sine of 75. It's always with the opposite, okay? Once again, if I use these two, I can calculate F2U, but F2U, you see, is going to be 6. There's nothing to do here because 6 divided by sine 75, F2U sine 75, so F2U is going to be 6 kilonewton, and F2V is going to be, I'm going to do this one, so it's going to be 6 divided by sine 75 multiplied by sine 30. 6 divided by sine 75 multiplied by sine 30, and that's going to be 3.11 kilonewton. Now keep in mind, very important, this one is negative because points in this way, and this is the positive direction, so this is negative. Now these are the components of the forces. I have to find the resultant force in the U-axis will be 2.07 plus 6, and the resultant force in the V-axis will be 2.93 minus 3.11. So this is going to be 0.07, and this is gonna be, it's negative, but I really, if I'm just focusing on the projections, yes, I need that in the b-axis. So that's going to be 3.11 minus 2.93, 0.18 kilonewton. That only means that goes in the opposite direction of what was intended there. Now, what do we have? We have this. Let me see if I can draw that again. Where's my thing? Here. Yeah, this is the v-axis, and this is the u-axis. B, U, 75 degrees. So I have a resultant force of 8.07 in this direction, 8.07, and I have in the other direction 0.18, so it's going to be in this way, that one, 0.18 in this way. What is my resultant force? My resultant force is going to be parallelogram, parallelogram. The resultant force is going to be that one. What is the value of this angle here between those two? I need that. I need that. I might use something else because I can use law of sine again if I want to. But let's use that. Let's use that one because it's easier. This is 75 degrees because this is 75 degrees. Okay, this is 360 because it's a full circle, right? 360. 75, 75, that's 210. That means this is 105. And this angle is 105. And then we can apply the law of cosines. It will be, remember the law of cosines basically is if you have a triangle ABC, then it's the A squared plus B squared. So my resultant force squared, let me put it like that, is going to be equal to this component square, 0.18. Don't include the sign because we're calculating basically distances here. And the sign will be assigned later on by U plus 8.07 squared, which is the other one, minus 2 times 0.18 plus 8.07 times cosine of 105. So that means that the resultant square here, it will be 0.18 square 0.18 square plus 8.07 square minus 2 times 0.18.8.07 times cosine 105 close, and this has to be a square root of that. So the resultant force, I took the square root already, would be 8.12 kilonewton. I'm just curious to see the result. I hope that I didn't mess up like before. Was it? This was it. Okay, yeah, basically it's the same thing. 8.1, 8.03, 8.03. So yeah, that will be the solution for that problem. Cool. We didn't mess up. I hope. At least we got the solution right. I'm very close. See you next problem, guys. Have a good day.